Welcome to another deep dive. We've pulled together a stack of sources. You shared a really practical guide this time, and we're cracking it open to pull out the core insights.
Yeah, and the focus today is understanding how to build these, well, powerful AI agents. This guide, it offers some great frameworks and best practices, stuff drawn from real-world use.
So our mission right now seems pretty clear. What are these agents really? When do you even think about building one instead of, just using regular software?
And then the fundamentals. What components do you need? How do you design them, get them working together, the orchestration piece?
Right. And crucially, how do you make them reliable and safe? That seems huge.
It really is. It's where a lot of the practical hands-on AI work is happening right now.
Okay, so let's dive straight in. What exactly is an agent? Because I feel like that term gets thrown around quite a bit. What's the definition this source is giving us?
Well, the guide defines them pretty simply. Systems that independently accomplish tasks on your behalf.
Independently. That's the key word there, isn't it?
Exactly.
So this isn't just like my project management software streamlining a workflow for me where I'm still clicking the buttons.
Right.
And it's apparently different from even simpler AI, like a basic chatbot or something.
Absolutely. And that's a really critical distinction the source makes. They explicitly say, look, simple chatbots or single-turn models or even just AI features like, say, sentiment analysis, those aren't agents.
Okay, why not? What's the dividing line?
Because they don't control the execution of a workflow themselves. They respond, sure, but they don't manage a multi-step process autonomously. They don't make the decisions about what happens next in the flow.
Gotcha. So, okay, what does an agent have to do then to actually earn that agent title? What are the characteristics it absolutely needs?
Okay, first, it has to use a large language model, an LLM, to actually manage that workflow execution.
Right, the LLM is doing the driving.
Yeah, the LLM makes the decisions along the way. It needs to figure out, okay, am I done with this task? It needs to be able to correct itself if it makes a mistake.
Self-correction, interesting.
And crucially, it has to recognize when it can't complete the task, when it's stuck and needs to hand off, usually to a human user.
So the LLM is kind of the brain, managing the whole flow and making those judgment calls. What else?
Second big piece, it needs access to tools.
Tools.
These are how it interacts with the outside world. Getting information, taking actions in other systems.
Right.
And the agent has to dynamically select the right tool at the right moment based on the situation. And importantly, it always has to operate within defined safety guardrails.
That dynamic tool selection plus the LLM actually controlling the workflow, that really feels like the core difference compared to, say, older automation or those simpler AI models we talked about.
That's exactly what the source emphasizes. It's that autonomous, reasoning-driven control over a process. That's the heart of it.
Okay, I think I get what they are now. But they also sound, pretty complex to build. So when should you actually consider going down this agent path? The source suggests it requires a kind of different mindset.
It really does. You have to rethink how you handle decision-making and complexity, especially if you're coming from a background of traditional deterministic systems, rule-based stuff.
Yeah, the payment fraud analysis example they use really nails this. If you try to catch fraud with just a traditional rules engine, it's basically a strict checklist, right?
Totally. If transaction amount is over X and the location is Y, then flag it. Very rigid.
Exactly.
An LLM agent, though, the guide paints it more like a seasoned investigator. It looks at the whole picture, the context. It considers subtle patterns, weighs different bits of information.
So it might flag something suspicious, even if it doesn't tick every single box on a simple list.
Precisely. It handles that nuance, that ambiguity, much more effectively.
Okay, that analogy really clarifies where the power lies. So building on that, what kinds of workflows are really suited for agents? Where do the traditional methods kind of hit a wall?
The guide points to three main areas where agents really shine. First is complex decision-making. These are workflows that need, nuanced judgment, lots of exceptions maybe, or decisions that really depend heavily on the specific context.
Like that customer refund example. Sometimes it's simple, but often you're weighing the policy, the customer's history, the specific complaint. It's not just a yes or no.
Exactly. A traditional system would really struggle with that gray area. That's prime territory for an agent.
Makes sense. What's the second type?
Difficult to maintain rules. Some systems just build up these massive, tangled webs of rules over years and years. Keeping them updated becomes incredibly costly, super error-prone, The source mentions vendor security reviews as an example. Imagine trying to write a strict rule for every possible risk factor or compliance check.
Yeah, that sounds like a maintenance nightmare waiting to happen. Okay, and the third area.
Heavy reliance on unstructured data. Basically, any scenario that involves understanding natural language, pulling meaning out of documents, or having, extended back-and-forth conversations.
Like processing a home insurance claim. You've got damage reports, emails, maybe photos, policy docs.
Perfect example. The agent needs to read all that, interpret it, figure out what's relevant, and then act on that messy, human-generated data.
So if your workflow involves that kind of complex judgment or rules that are just spiraling out of control or lots of messy text, an agent might be the way to go.
That's the idea. But the guide adds a really important note of caution here.
Okay.
Before you jump into building an agent, really validate that your use case clearly falls into one of these buckets. Because if a simpler, more deterministic solution can actually handle it, that's probably still the better, easier path.
Right. Don't use a sledgehammer to crack a nut.
Exactly. Agents are for those problems that have historically been just too complex or too fuzzy for traditional automation.
Got it. So they're powerful, but a specific tool for specific kinds of complex problems. All right, let's say we do have one of those use cases. How do we actually start building one? Let's get into the nuts and bolts. The source breaks it down into 3 core design foundations.
Right, the essential ingredients, you'd say. The model, the tools, and the instructions.
Okay, let's start with the model. That's the LLM itself, right?
Yes. And a key point here is you don't necessarily need the biggest, most powerful, most expensive model for every single task the agent performs. Different models have different strengths.
Yeah.
And importantly, different trade-offs.
Yeah.
Complexity they can handle versus latency versus cost.
So maybe a simple job like classifying an incoming email could use a smaller, faster model.
Exactly.
While something requiring deep reasoning, like drafting a complex response, would need a more capable one.
Precisely. And a practical strategy the source recommends is maybe start prototyping with the most capable model you can get your hands on. Use it for everything initially.
Establish a baseline.
Yeah, set a performance baseline. Then you can start experimenting. Swap in smaller, cheaper, or faster models for specific subtasks. But, and this is crucial use evaluations, evils, to make sure you're still getting acceptable results for that specific part of the job.
So you optimize for cost and speed, but only where you can prove it doesn't hurt the outcome too much.
Exactly. It's about finding that sweet spot. Make it work first, then make it efficient.
Smart. Okay, second foundation. Defining tools. These are the agent's connection to the outside world, you said.
Right. How it actually does things or gets information.
Using APIs from other systems, or maybe even controlling a computer interface for older software that doesn't have APIs.
Yeah, things like that. And the guide really stresses that these tools need to be standardized, well-defined, thoroughly tested, and reusable.
Why is that so important?
Well, it makes them easier for the agent to actually discover and select the right one. And honestly, it makes them much easier for you to maintain over time. Consistency helps everyone.
Okay. And they break down the types of tools into 3 broad categories, which seems helpful.
Yeah, first are data tools. These are all about fetching information.
Getting context.
Exactly. Querying a database, reading a specific document, maybe searching the web for current info. They feed the agent the knowledge it needs.
Okay, gathering intel. Makes sense. Second category, action tools.
Right. These are for doing things. Sending that email, updating a customer record in your CRM, submitting an order form, maybe handing off a support ticket to a human agent. They let the agent actually affect the real world, so to speak.
Okay. And the third type is interesting. Orchestration tools. This is where agents can call other agents.
Exactly. You might build a specialized agent, say a refund processing agent that knows everything about handling refunds. Then another agent, maybe your main customer service agent, could call upon that refund agent as if it were just another tool whenever a refund is needed.
So agents can kind of build on each other's specialized skills. That's neat.
It allows for modularity. And I think you notice the source mentions, if your single agent starts needing a huge number of tools, that itself might be a sign.
A sign that maybe it's time to split the work.
Yeah, maybe you need to break it down into multiple, more focused agents. Which brings us neatly to the next big topic, orchestration.
Right. How do you actually make these agents or groups of agents execute a full end-to-end workflow?
That's orchestration. And the guide's advice here is really clear. Start simple. Please, start simple. Begin with just a single agent handling the workflow before you even think about jumping into complex multi-agent architectures.
Okay, so they categorize orchestration into single agent and multi-agent systems. Let's talk single agent first.
A single agent system is pretty much what it sounds like. One agent, armed with its tools and instructions, handles the entire workflow from start to finish.
And it can actually handle quite a lot just by incrementally adding more tools to its toolkit, right? As long as you manage the complexity.
Absolutely. The core concept they describe is this run process. It's typically implemented as a loop. The agent thinks, decides on a tool, uses the tool, gets a result back, thinks again based on that result.
Lather, rinse, repeat.
Kind of, yeah. And this loop continues until it hits some kind of exit condition. Maybe it successfully completes the task, or it generates the specific structured output you asked for, or maybe it hits an error it can't recover from, or it just hits a maximum number of turns you've set.
Okay. And within that single agent model, how do you keep it from getting too complex as you add more tools or handle more variations?
A really effective strategy the source highlights for managing complexity without immediately needing to split into multiple agents is using prompt templates.
Prompt templates. Tell me more.
So instead of writing a completely new bespoke prompt for every single slightly different scenario the agent might face, you create a single, flexible base prompt. This template has variables or placeholders in it.
Okay.
Then for each specific task instance, you just plug in the relevant details, the customer ID, the specific request, maybe some policy details into those variables. The agent uses the same underlying logic structure defined in the template, but applies it to the specific context.
Ah, I see. So you maintain one core prompt structure, which is way easier than managing dozens of slightly different ones.
Exactly. It simplifies maintenance dramatically and helps keep that single agent manageable for longer.
That sounds really key. But okay, eventually, even with prompt templates, a single agent might hit its limits, right? When do you really need to consider splitting the work across multiple agents?
The source gives two main indicators. One is when you have genuinely complex logic. Meaning, if your single agent's prompt template starts getting absolutely stuffed with conditional statements, tons of if this, then do that, but only if this other thing is true. Otherwise, if condition Z applies, to do this other thing.
Yeah, branching logic, hell.
Right. It just becomes brittle, hard to read, hard to update without breaking something else. That complexity suggests the underlying task logic might just be too much for one agent brain to handle cleanly.
Okay, so the brain is getting overloaded with too many if-then-else paths. What's the other big indicator?
Tool overload. Or maybe more accurately, tool confusion. Sometimes it's not just the sheer number of tools, but the fact that many tools might seem quite similar, or their purposes overlap.
The agent struggles to pick the right one.
Exactly. Even if you try really hard to improve the tool clarity, better names, better descriptions, clearer parameters, if the agent consistently fumbles and picks the wrong tool from a set of similar options, it might be a sign that you need more specialized agents. Each specialist agent would have a smaller, much clearer, more distinct set of tools relevant only to its specific task.
Got it. So complex decision logic and persistent tool selection confusion are the big red flags saying time to distribute the intelligence. Yeah. And that's when you move into the world of multi-agent systems.
Precisely. In these systems, the workflow execution is distributed across several agents that need to coordinate and work together. Often this is modeled kind of like a graph with tasks flowing between agents.
And the source highlights two common patterns for how these agents can work together, right?
Yeah, two broadly applicable patterns. First is the manager pattern.
Okay, manager pattern. Sounds hierarchical.
It is. You have one central manager agent. This agent essentially orchestrates the work by calling upon other, more specialized agents as if they were tools.
Like the orchestration tools we mentioned earlier.
Exactly. So the manager gets the initial request from the user, figures out which specialized agent is needed for the next step, calls that agent, gets the result back, maybe synthesizes results from multiple specialists, and generally maintains the interaction with the user throughout the whole process.
So the user talks primarily to the manager agent?
Usually, yes.
Oh.
It's great when you need one agent to maintain that overall control, manage the state, and handle the user interface consistently.
Like that translation example in the source. A manager agent gets a text, figures out it needs Spanish, French, and Italian versions, calls the specialized Spanish agent tool, the French agent tool, the Italian agent tool, gets all the translations back, and then presents the combined result to the user.
Perfect example. The manager directs the traffic and puts the final package together. Okay, the second main pattern is Decentralized.
Decentralized, so less hierarchy.
Yeah, here the agents act more like peers in a team. They hand off tasks to one another based on who is best suited for the next step in the workflow.
How does the handoff work?
Well, it's often implemented as a specific type of tool call, but one that transfers more than just data. It transfers the execution state where things are in the process, and often the ongoing conversation history as well.
So the user might start talking to one agent and then get handed off.
Exactly. The initial agent might figure out what's needed and say effectively, okay, this is an order management issue. I'm now handing you over to our order management specialist agent. And the conversation continues directly with that second specialized agent.
Like that customer service triage example they gave. A first agent figures out you have an order problem, and instead of just telling an order management agent about it behind the scenes, it actually transfers the whole interaction, context, history, everything directly to that specialist agent to take over.
Precisely. This pattern works well when no single agent really needs to oversee the entire end-to-end process or synthesize all the results. Different specialists can just take full ownership of their part of the workflow when it's handed to them.
Interesting. And the source mentioned briefly, you can build these multi-agent systems using different approaches, like defining the graph structure up front versus coding it more dynamically.
Yeah, they touch on declarative frameworks where you explicitly define the workflow graph beforehand versus code-first approaches where you use familiar programming constructs to orchestrate the agents. The implication was that code-first often gives you more flexibility for more dynamic or complex workflows.
Okay, fascinating. So we've covered what agents are, when to build them, the core design components, models, tools, instructions, and these different ways to orchestrate them, from single agents with templates to complex multi-agent managers or decentralized teams. Now, the big one. How do we make sure these things don't, go off the rails or do something harmful? That's where guardrails come in, right?
Absolutely essential. Guardrails are your layered defense mechanisms. They're there to manage risks, things like data privacy breaches, reputational damage for your company, or just outright safety issues.
And they're meant to work with standard security measures, not replace them. Yeah.
Definitely. They're a complementary layer, often focused specifically on the risks introduced by the LLM's generative and decision-making capabilities.
And the key idea seems to be layering different types of protection, not just relying on one thing.
Exactly. Combining different approaches, maybe some checks done by another LLM, some based on simple hard-coded rules, maybe calls out to external moderation APIs. You want defense in depth.
Okay, so what are some specific types of guardrails the source mentions?
Well, a basic but really crucial one is a relevance classifier.
Relevance.
Yeah, it just flags queries or inputs that are completely off topic for what the agent is supposed to be doing.
Like asking your banking support agent for a movie recommendation.
Exactly, or trying to get it to write code when it's supposed to be processing insurance claims. It keeps the agent focused.
Makes sense. What else?
Then there's a safety classifier. This is more focused on detecting actively malicious or unsafe inputs. Things like jailbreak attempts.
Trying to trick the model.
Yeah, trying to get it to ignore its instructions or reveal its system prompt or perform harmful actions. Also, prompt injections, where users try to sneak instructions into their input.
Right, gotta watch out for those.
Then, super important for privacy, a PII filter, personally identifiable information. This guardrail vets the model's output before it's shown to the user, trying to catch and redact any accidental exposure of sensitive data, like names, addresses, credit card numbers, etc.
Crucial. Don't want the agent leaking customer data.
Absolutely not. And related is general moderation. This often uses external APIs or models to flag harmful or inappropriate content in either the user's input or the agent's potential output. Things like hate speech, harassment, promoting violence.
Standard content filtering, but applied to the conversation.
Pretty much. They also talk about tool safeguards. This is about assessing the risk level of each tool the agent can use.
How risky is sending an email versus, say, deleting a customer account?
Exactly. You might classify tools as low, medium, or high risk based on factors like what data they access, whether their actions are easily reversible, and what the potential impact of misuse is. High-risk tools might then trigger additional checks, maybe require human approval before the agent is allowed to use them.
Smart. Adds friction where the stakes are highest.
Then you have your simpler rules-based protections. These are deterministic checks. Things like block lists for known bad words or malicious patterns, maybe strict limits on input length to prevent certain kinds of attacks, or using regular expressions, regex, to spot known dangerous input formats.
The classics still have a role.
They do. Easy to implement, very predictable. And finally, output validation. This is often about ensuring the agent's responses align with your brand, voice, tone, and values. You can use prompt engineering, respond in a helpful and professional tone, and maybe even have another model check the output for compliance.
Okay, that's a lot of layers. How do you decide which ones to implement and when?
The guide offers a pretty practical heuristic, a rule of thumb. Start with the absolute essentials: data, privacy, and safety. Get those TII filters and basic safety classifiers in place first.
Table stakes.
Right. Then add more guardrails incrementally. As you test the agent and deploy it, you'll inevitably discover real-world edge cases and failures. Use those incidents to decide what new guardrails are needed. Did it hallucinate something dangerous? Add a check. Did it leak internal info? Beef up the filters.
Learn from mistakes.
Exactly. And finally, optimize. Continuously tune your guardrails to find the right balance between robust security and a smooth, non-frustrating user experience. You don't want overly aggressive guardrails blocking legitimate use cases.
It's a balancing act. Okay, and maybe one of the most important guardrails, especially when you're just starting out with an agent, isn't purely technical. The source talks a lot about planning for human intervention.
Absolutely critical. You have to accept that the agent will encounter situations it can't handle, especially early on. Human intervention is a planned, graceful way for the agent to say, "I'm stuck," or "this is too sensitive for me," and hand control over to a human.
So it's not just about the agent failing silently, it's about a smooth handoff.
Yes. Whether that's escalating a complex customer service issue to a human agent in a call center, or maybe just handing control back to the user in an application and saying, "I need you to clarify this part," the transition has to be designed and smooth.
What typically triggers that handoff? When does the agent know it's time to call for help?
The source highlights two main triggers. One is simply exceeding failure thresholds. You set limits.
Like, try this action 3 times. If it fails, escalate.
Exactly. Or maybe, if the agent has gone back and forth with the user 5 times and still hasn't resolved the issue, it's time for a human. Don't let it just spin its wheels indefinitely.
Prevents user frustration, too.
Definitely. The other major trigger is high-risk actions. Any action the agent might take that's particularly sensitive, potentially irreversible, or has significant financial or user impact.
Like canceling someone's order, or authorizing a big refund, or making a payment.
Precisely those kinds of things. For actions like that, you should strongly consider building in a mandatory human review step, at least initially. The agent proposes the action, but a human has to approve it before it actually happens.
Build up confidence over time before letting it run fully automatically on high-stakes tasks.
That's the idea. So human intervention isn't really a sign that the agent has failed. It's a necessary, planned component of building a safe, reliable, and effective system that works in the messy real world.
Yeah, it acknowledges the limits of the tech right now and prioritizes keeping things safe and making sure the user actually gets their problem solved.
Precisely.
Wow, okay. That guide really laid out a clear, comprehensive path. We went all the way from just defining what an agent even is and figuring out when they're actually the right tool for the job.
Yeah, understanding those specific use cases where they shine.
Through the fundamental building blocks you need to design them, the models, the tools, those crucial instructions.
Getting those foundations right.
Then how to actually make them run the workflows, using different orchestration patterns, starting simple, moving to multi-agent systems if needed.
Single agent first, then manager or decentralized pattern.
And finally, maybe most importantly, how to build in those critical layers of guardrails for safety and reliability, and planning for that essential human oversight and intervention.
It's a lot, but agents are genuinely changing the game in automation, aren't they? They can tackle complex, multi-step tasks with a kind of autonomy we haven't really seen widely deployed before.
And it's because they can reason through ambiguity and dynamically use those tools.
That seems to be the core capability, yes.
And the big takeaway for anyone listening who's thinking about building one seems to be, get the foundation solid. You absolutely need capable models, well-defined tools, crystal clear instructions. That's non-negotiable.
Absolutely. Choose the right orchestration pattern for your complexity level, probably starting simple. Layer in those guardrails thoughtfully at every step. Security and safety aren't afterthoughts.
And plan for that human handoff. Design it in from the start.
Right. It's not a build it once and forget it kind of technology.
Yeah.
It's iterative. You start small, you validate with real users, you learn from the inevitable failures and edge cases, and you incrementally build up the capability. That's really the path to creating agents that deliver real, reliable value.
It really does make you stop and think, though. When you have systems that start making decisions, taking actions on our behalf with this level of reasoning and autonomy.
Yeah. Where are you going with that?
Well, what new layers of responsibility do we, as the people building and deploying these things, take on? What does it really mean to be accountable for a system that's not just executing pre-programmed code, but is actually reasoning, choosing tools, and making judgment calls? Something to keep in mind, I think, as you explore building your own agents.